So hello everyone, I will be giving Leetcode bi-weekly. So question 4 is here. Let's start solving from question 4. Or last time we have already done this mistake of solving from question 4. So let's now start from the question 1. You're given an integer array nums consisting of only 0, 1 and 2. A pair of indices I and j is called valid if nums of I equal to 1, nums of j equal to 2. Return the minimum absolute difference between I and j among all valid pairs. If no valid pairs exist, return -1, the absolute difference between. Okay, done. So let's take last equal to -1 to count the last one, and last two equal to -1. Let's take some max for type equal to 0 and mouse dot size I plus plus. Let me correct my keyboard. Okay, done. Yeah. So if nums of I is equal to 1, last one would be equal to I. Answer equal to minimum of answer comma this formula ABS of last one minus last two. Let's decrease the font. Font is too big for me. Let's make it 15 should be fine. Yeah, done. Okay, so this would be the answer. And similarly, if nums of I is equal to 2, then last two would be equal to I, and if last one is not equal to -1, again do the same. Just do the same. Okay, and let's return this after the for loop. Where's the for loop? Here, right? Return answer equal to if it's equal to int max, then return -1, otherwise return answer itself. Let's see if this works. A very basic logic. What we are asked to do, we are exactly doing the same. So 2. Okay, fine. I guess it would pass. Yeah, done. Accepted. Now, yeah. Now let's move to the next question. Okay. What does the question say? You're given 3 integers n position and k. There are n people standing in a line index from 0 to n -1. Each person independently chooses L visible only to people on the right, R visible to on the left. Okay, a person at index position sees. Okay, return the number of possible direction assignments such that the person at index POS sees exactly k people. The person at index POS sees exactly k people. Okay. Okay. Let's do it later. It seems a bit complicated. I don't know why. So let's move to the third question. You are given a 2D integer array grid of size m cross and you start at the left, okay, bottom right cell, right or down. The cost is defined as bitwise sort. Okay, a simple traversal would be enough, I guess. A simple traversal. So let's take int n equal to grid dot size, int n equal to grid of 0 dot size, Okay, so this should be the visitor. Looks like a complex data structure, but yeah, this should be working. And we'll push 0 0 grid of 0 0 grid of 0 0. So far this thing is visited, and visited of 0 0 will mark it as, we'll insert grid of 0 0 here. Okay, so answer is equal to int max initially, because we are minimizing the cost, so it should be int max and a simple BFS kind of thing. Okay, x y is equal to q dot front and q dot pop. Okay, and what else? When are we going to stop this? Y equal to n minus 1. Answer equal to minimum of answer and val. Okay. You can move right and down. So you can move right and down. Okay, so this is down, this is right, and now it's time to visit the neighbors. Dx dy directions. New x equal to x plus dx and new y is equal to y plus dy. Okay, if nx is less than m and ny is less than n, that is a grid of nx and y. It's almost like any other shortest path problem. You're just modifying some data structures and calculating the XOR instead of summing up things, isn't it? So if not visited of, if new x, new y, or the neighbors aren't visited, just like, okay, let's count this. It was an unordered set, right? So if we count this, visited of nx, visited of nx and y dot insert ny and q dot push nx ny should work, hopefully. What's the problem here? Vector pair int. No matching constructor. Vector pair int. Fine, no problem. No matching constructor for initialization. What happened? There are two elements, so it should be fine. Okay, this is not how we are supposed to initialize, right? Sometimes I forget the syntax. it exceeded. Still it passed a lot of test cases, so let's have a look at it later. Let's go to the fourth problem now. So what does the fourth problem say? You're given an integer array digit sum of length n. An array ARR of length n is considered valid if... Okay. Let's declare this modulo thing first. Wait, am I getting recorded? No, done. Okay, and let's do this in digits something. Let's call it DG of index. This will denote the digit sum, and we already know how to do this digit sum. Sum plus equal to last digit, and shift the number. This would give the sum of digits. It's a very basic program. And int n equal to, let's name it something else. Let's call it d dot size. Fine. Unordered map int vector int. Let's call it f. Okay. Sorry, f of dot pushback I. That's it. Okay. Let's make this DP thing and value in f of d of 0. Are we doing it right? Value in f of d of 0. I'm trying to do a base case thing. So db of 0 val, yeah, the states, this would work out. The states are like, they're fine. Pre-value and base. For int val in f of d of I. If val greater than or equal to, if val greater than or equal to pre, dp of I val would be equal to d of I val plus Let's ways. Done. Uh, okay, so let's try submitting it. Once again, a TLE. I was like, I thought this would, okay, since we're using a map, I thought it won't take that much amount of time. Okay, but we need to think about it. What if we try to pre-compute the count? What if we try to pre-compute the count? Would that work properly? It would take some more 5,000. Fine. This is a good contest, to be honest. Digit sum, let's keep it as it is. Okay, let's remove this part. Let's pre-compute the count. Okay. Count of DG of I plus plus and now since it's pre-computed we can use it and we can reduce the states dp of d of 0 equal to, you can directly write count of d of 0 new dp Let's calculate prefix sum from here. Plus dp of s new dp of s is equal to p of s multiplied by count of s actually you can do a mod here itself. dp equal to ndp answer equal to 0 for auto ndp and return answer. This should be working. We have reduced the states by a great extent, but it's giving me 0. Okay, so what happened? Okay, let's move to some other question. Let's move to the third question again. Can I do something like, okay, wait. Got it. What if we do meet in the middle? Front and back and or DFS one. Okay. Y is equal to grid of xy. If steps front of x comma y n plus n minus 2 minus n plus n minus 2 divided by 2. If this is the case, that of x comma y push back val return give us to of x minus 1, sorry, x minus 1 y. Grid of x1 The time complexity of this was supposed to be 2 power n by 2. Okay, so We are today we are short of time. Wasn't supposed to happen. We have solved only one question. Let's quickly solve a few more. I'm thinking upon this. Why is meet in the middle not working? Mhm. We can't optimize this part. We are pre-computing this. We have reduced the DP state. This part is something that we should worry about. This question, can it be solved in a better way? Is there any other state idea for this? So let's forget the previous approach. Let's start fresh. To solve this problem, we need to find the non-decreasing arrays where elements ARR of I has a specific digit sum. So first thing we need to do is grouping, right? Constraints are okay, whatever. So value by sum, let's take it of size 46. I feel it's 46. Am I right? Yeah, it should be 46. Previously we took it as 50, but yeah, it can be 46. So previous dot pushback I, and vector long dp max value plus 1 0. Pushback. Okay, wait. Previous surface dot pushback. Yeah, done. Finally. Fourth question is done. Now let's move to the third question. Out of time. To the integer array grid. far everything seems right. The reason for the TLE is, I guess, this part. The DFS is something we cannot optimize more than this. Is there any other way other than meet in the middle? Hmm. Okay, wait. Hmm. The previous implementation where we took this. Previous equal, previous and give you 5 minutes for MG. Media of IG dot insert yes or the grid of IG. Wait, are we inside this for loop? Should be here. Yeah, done. Direction assignments with exactly K visible people. We just have 40 minutes left. Should we have a look at the ranking? Okay, some people have done all of them. Mhm. Okay, so this much efforts for NCR. I hope you know what I have done. Now, let's pre-compute the factorials. Factor of 0 equal to 1 and I plus factor of I. Yeah, done. Okay, so the Leetcode contest is done, guys. Thanks for that. And okay, so now it's time to see. Okay, wait, let's see the rankings first. First thing, let's see the rankings. Let's go to the rankings page. 988. That's bad. In previous contests, we were around 200, 145, I guess. So that's a downfall. But yeah, that's fine. Every day is not that great. But by the time of weekly contest again, I can push. Okay. So let's move to the solutions part first. The previous video I have uploaded, there was a comment which asked me my explanation was pretty bad. Yeah, which is true, because yeah, it's a contest, right? You are already frustrated. Okay, and the rank is falling. Okay, anyways. So coming to the fourth question, should I start from the fourth question? That should be fine, right? Okay, let's start from the fourth question. So you're given an integer array digit sum of length n. Let me read the problem statement first for you. Of length n, an array ARR of length n is considered valid if ARR of I values lie in between 0 to 5000, which is non-decreasing. It should lie 0 to 5000. It is non-decreasing. The sum of digits of ARR of I is equals to digit sum of I. The sum of digits of ARR of I is equal to digit sum of I. Fine. Return an integer denoting the number of distinct valid arrays. Since the answer may be large, return it in modulo 10 power 9 plus 7. An array is said to be non-decreasing. Yeah, we know what's non-decreasing. So, okay. So the first observation is, to solve this problem, we need to find number of non-decreasing arrays where, okay, this is too big, the font is too big, where array of I has a specific digit sum given by digit sum of I. Okay, so the sum of digits of A of I is equal to digit sum of I. Since each element in A of I is constrained between 0 to 5000, it cannot cross this, right? It's constrained in between 0 to 5000, and the array must be non-decreasing. Now you have a constraint. Tell me, is there a better way than checking out all the possibilities? Can you somehow greedily figure out uh, the valid arrays? Mostly not, because you see, uh, distinct valid arrays, since the answer may be large, so there are many possible answers. You cannot use any greedy technique, as far as I think. You cannot, right? There's no particular logic which suggests the count. You cannot figure out the count. So the only way you're left with is trying out all the possibilities. And uh, the answers may be overlapping because there are multiple numbers. Each one is independent. So that means there could be overlapping subproblems, which means you can use something called DP. Okay. As you also in the solution part where I was giving the contest, the direct DP approach kind of failed. Isn't it? So the first thing I can think of when the situation is the normal DP approach has failed, can I optimize on time because I got time limit exceeded? Can I optimize further on time? Okay, so I can see that um, to optimize on time, I should look at something that would take lesser time. So I would go for some sort of a pre-computation which would help me simplify the dynamic programming, like simplify the states of the dynamic programming, and also it should be taking the lesser time. So can I do this somehow? Since I have a constrained range, can I pre-compute for this range? Yes, I can pre-compute for this range. Okay, so it's nothing but making buckets. It's like making buckets. First we group all integers from 0 to 1000 by their digit sum. Okay, all the numbers between 0 to 5000 whose digit sum is some x would be in the same group, like 21, 12, etc. All these things would be in the same group. Okay, so you're grouping by the digit sum. This allows to quickly retrieve all the possible values for a digit sum, isn't it? Now you just need to find how many values are there for a digit sum. So now I can simplify the DP state. DP of IV is equal to number of valid sequences of length I ending with value v. This would be the state ending with value v, isn't it? And transition, how to figure out the transition for this? Okay, to calculate DP of IV, what's DP of IV? Number of valid sequences of length I ending with v. So we sum up we sum up to all dp of I minus 1 to whatever the previous values of v are there, and previous values of v are always less than or equal to v, isn't it? Previous values of v are always less than or equal to v. Okay, and we need to make sure that previous of v is a valid value for digit sum of I minus 1. We'll later understand how to check that validity. So the naive DP approach would give you n into 5000 square, isn't it? Which is too slow. And that 5000 square part you are optimizing using the prefix sum. This is the basic idea of the fourth question. And honestly, this wasn't intuitive for me also. I thought like, okay, it's 5000 square, so yeah, I thought, I guess it's stupid. I don't know why it was not intuitive. I just missed this. 5000, it would go to 5000 square. I missed this, honestly. So, what's the solution that I have written? How is it working? First thing, all these things are like fine. N equal to d dot size constant. Yeah, mx equal to 5000. Yeah. Coming to this thing. What are we trying to do here? What is this VBS? This VBS is value by sum. What it stores? It stores max sum. It stores max sum for 5000, which is 4 plus 9 plus 9. How much is this? It's 31. Yeah, it's 31, right? So for int I equal to 0, I less than or equal to mx I plus plus. This is, we are calculating the digit sum. So value by, we are grouping it, right? From 0 to 5000, whatever the sum you're getting, you're putting them into groups. So if I has a sum s, it would be going into VBS of s. This is what you're doing. Till this part, what have you done? You have grouped the values based on sums, isn't it? And vector long dp of mx plus 1 comma 0, int first sum equal to d of 0, first sum greater than or equal to 46. In that case you would return 0 for int v, because we are storing value by sum till this only. So if the first sum is this thing, it's of no use to us because the value won't lie inside the 0 to 5000 range. The value won't lie inside 0 to 5000 range. So for int v in VBS of first sum, dp of v equal to 1. Okay, dp of v equal to 1. What's dp of v? The number of valid sums. And for int I equal to 0, I less than and I plus plus, nxt mx plus 1 0, and this part is prefix sum. Okay, so to this you are adding dp of v, which is the valid number of v's, and current sum is equal to d of I. If current sum is greater than or equal to 46, return 0 because that's not of your use. And for int v in VBS of current sum, nxt of v equal to p of v plus 1. Basically, this is what you're doing. Where is it? You're calculating this sigma. You're calculating the sum of all the previous values. You're calculating the sum of all the previous values. Okay, because we already know dp of iv, which is nothing but length I ending at v. So we sum all the previous values up to we sum up all dp of I minus 1 previous v, where previous v is less than or equal to v. So no need to write this particular state because we have already done the pre-computation for it, which is prefix sum. So that state can be ignored now. That's the optimization, right? Essentially. So yeah, this would work. Coming to the third question. Okay. To solve this problem, we were supposed to find a path from top left to bottom right using only two operations, which is right and down, isn't it? You could only do right or down move, such that cumulative sum is minimized. Okay, so the first intuition for this problem is also I need to check out all possibilities, isn't it? I need to check out all the possibilities, for which I would use DP probably, right? So a standard DP approach would track every possible XOR sum at each cell. What if your XOR sum crossed 1000, or to be precise, it crossed 1024 or higher? The state space would be m cross n cross 1024. This and our grid sizes. Okay, it might be very slow and it would be memory intensive because if you see, it's 1000 into 1000 into 1000, so it's somewhere around 10 power 3 into 10 power 3, which is 10 power 3 whole square, and it's basically 10 power 3 whole cube, isn't it? So this is a quite huge one. It's not possible. It might be too slow or memory intensive for tight constraints. Instead, we use something known as meet in the middle. What does this do? In forward pass, in forward pass, what you're trying to do is start from 0, 0. You start from 0, 0 and traverse to the middle of the grid. Mid grid. So traverse to the middle of the grid, right? Okay, how to actually know this is the middle grid? It's r plus c equal to half distance. And during this path from 0, 0 to middle of the grid, store all possible XOR sums. In a hash set. And in backward pass, you go from m minus 1 n minus 1 to the same middle cell. Okay, in forward pass you move from 0, 0 to middle of the grid, and in the backward pass you move from m minus 1 n minus 1 to the middle of the grid. Okay, to combine these two, at the end we need to get the final answer, right? The valid answer for both passes. For each middle cell, compare XOR sums from the forward pass with the XOR sums from the backward pass to find the minimum possible XOR. Isn't it? How to combine this? Compare the forward pass XOR sums with backward pass XOR sums, and this would give you the total minimum XOR sum. So I'm still getting recorded. Sometimes OBS is stopping, I don't know why. Yeah, I'm still getting recorded. Yeah. So here, what did we try to do? I hope 1 and 2 questions are clear. They are not a big deal actually. M equal to grid dot size, n equal to grid 0 dot size. None of our business. Vector, unordered set int dp. Okay, what's dp of ij doing? What's dp of ij doing? dp of ij stores all possible jawsums to each cell ij. Okay, so base case would be the starting point for the forward pass, which is 0 comma 0. Okay, base case would be the starting point 0 comma 0, where you insert grid of 0 comma 0, and from here for int I equal to 0, I less than m, I plus plus, for int j equal to 0, j less than m, j plus plus. If both of them are 0, if I equal to 0 and j equal to 0, then yeah, simply continue from that iteration. Or else you could have written I equal to 1, j equal to 1 directly from here. Again, that's not a problem. And if I is greater than 0, if I is greater than 0, if we can, what does I is greater than 0 mean? What does I is greater than 0 mean? It means you're not at the topmost row. You're not at the topmost row. That means we can come from the top. We can come from the top. We can make a down move. A down move is possible. A down move is possible. So, what are we gonna do? If we can come from the top, if we can come from the top, which means I is greater than 0, you are calculating dp of ij. You're calculating dp of ij, which stores all the awesomes to reach till ij. So you're inserting previous XOR, and you're XORing the grid of ij. You're basically adding up the cost. And if j is greater than 0, that means you can come from the left. You can make a right move. You can come from the left. In that case also you are doing dp of ij dot insert prefix XOR, sorry, previous XOR, XOR grid of ij. So you're inserting all the possibilities. You're inserting all the possibilities from the previous leftward cells from where you can come. Okay, and we have already discussed the idea. Once you get this 0 to mid and m minus 1 n minus 1 to mid, you can simply do this minimum of mn comma f. So okay, this will give you the minimum, and this worked out. So I hope this is clear. The first two questions were kind of easy. While implementing them, I hope you have observed them, so that would have given you a clear intuition. So thank you everyone.